Did you know our moon might not be our only natural satellite? It sounds like science fiction, but it is a real scientific possibility. For decades, astronomers have been captivated by a strange and elusive idea. They have searched for mysterious objects that share our orbit around the sun. These are not solid, rocky moons like the one we see almost every night. Instead, they are something far more delicate and ghost-like. Imagine vast, thin clouds of dust silently traveling through space alongside our planet. These are Earth's hidden companions, a secret that the cosmos has kept from us for a very long time. These elusive objects are often called dust moons or ghost moons. The name perfectly captures their mysterious nature. They are incredibly faint and difficult to detect, almost like phantoms in the night sky. Unlike our bright, familiar moon, they don't reflect much sunlight. This makes them nearly invisible to even our most powerful telescopes on Earth. For years, their existence was just a theory, a whisper among scientists who studied the complex dance of gravity between the Earth and the moon. Proving they were real was a challenge that spanned generations of researchers, each one building on the last's work. Think about the night sky you know so well. You can see stars, planets, and of course our beautiful moon. But what if there was more? What if hiding in the darkness, there were two enormous clouds of cosmic dust, each one many times larger than our entire planet? These are the Kordylewski clouds, named after the Polish astronomer who first claimed to have seen them. They are so faint that you could stare right at their location in space and see nothing at all. Their story is one of patience, dedication, and the relentless human desire to uncover the universe's hidden secrets. The idea of Earth having more than one moon is not new, but the form these moons take is what makes this story so fascinating. The story of these dust moons begins not with a bang, but with a whisper. It started with mathematics, long before anyone had a telescope powerful enough to search for them. In the 18th century, a brilliant mathematician named Joseph Louis Lagrange made a stunning discovery. He was studying the gravitational interactions between two large bodies, like the sun and a planet, or a planet and its moon. He calculated that there were special points in space where the gravitational pull from the two large bodies balanced out perfectly. These points are now called Lagrange points, or L points, in his honor. Lagrange realized that a small object, like an asteroid or a cloud of dust, could orbit at these points without needing much energy to stay there. The combined gravity of the larger bodies would hold it in place, like a ball balanced perfectly on the top of a hill. For the Earth-Moon system, there are 5 such Lagrange points. 3 of them lie on the line connecting the Earth and the Moon, making them unstable. But 2 of them, known as L4 and L5, form a triangle with the Earth and the Moon. These 2 points are remarkably stable, acting like cosmic parking spots in space. This is where our story gets really interesting. Scientists began to wonder what might be hiding at these stable Lagrange points. Could small asteroids be trapped there? Could there be collections of space debris from the formation of the solar system? The L4 and L5 points of the Jupiter-Sun system are famous for hosting thousands of asteroids, known as the Trojan asteroids. So it was a very logical question to ask: does the Earth-Moon system have its own Trojans? This question sparked a celestial treasure hunt that would last for more than half a century. Astronomers knew exactly where to look. The L4 and L5 points are located along the Moon's orbit, one leading 60 degrees ahead of the Moon, and the other trailing 60 degrees behind it. The man who turned this mathematical theory into a potential reality was a Polish astronomer named Kazimierz Kordylewski. In the 1950s, he became obsessed with the idea of finding something at the Earth-Moon Lagrange points. He spent countless nights at his observatory, patiently scanning the skies. He was looking for a faint patch of light, a subtle glow against the blackness of space. It was a tedious and often frustrating task. The area he was searching was vast, and the object of his quest was predicted to be exceptionally dim, perhaps even dimmer than the faint glow of the Milky Way. In 1961, after years of dedicated searching, Kordylewski announced a groundbreaking discovery. He claimed to have photographed 2 faint cloud-like patches of light near the L5 Lagrange point. He had finally found them. He described them as being very large, covering an area of the sky about 6 degrees wide, which is roughly 12 times the diameter of the full moon. However, they were incredibly faint, only slightly brighter than the surrounding background light of the night sky. This made his evidence very difficult for other astronomers to verify independently. The ghost had been seen, but the proof was hard to grasp. Kordylewski's announcement was met with a great deal of skepticism from the scientific community. Many astronomers tried to repeat his observations but failed. The clouds were just too faint, too elusive. Was it possible that Kordylewski had made a mistake? For many years, the Kordylewski clouds remained in a kind of scientific limbo. They were more like a ghost story told among astronomers than a confirmed celestial object. Their existence was debated for decades, with some scientists firmly believing they were real and others dismissing them as observational errors. This uncertainty fueled the mystery surrounding these dust moons. So, what exactly are these mysterious Kordylewski clouds? Let's break it down. Imagine a cloud, but not one made of water vapor like the ones you see in our sky. Instead, these clouds are made of tiny specks of dust. We're talking about particles smaller than a grain of sand, maybe even as small as the particles in smoke. These bits of cosmic dust are floating together in the vast emptiness of space. They are not held together by chemical bonds or any kind of sticky substance. Instead, they are gently corralled by the invisible force of gravity, forming a massive yet incredibly sparse collection of interplanetary debris. These clouds are not solid objects. You couldn't land a spaceship on one. In fact, if you were to fly a spaceship right through the middle of a Kordylewski cloud, you might not even notice it. The dust particles are spread out over an enormous volume of space. Scientists estimate that the distance between individual dust particles could be quite large. It's more like a very, very thin fog than a dense cloud. This is one of the main reasons they are so hard to see. They don't block light like a solid object, and they don't reflect much sunlight back towards us here on Earth. They are almost transparent. The dust itself likely comes from a variety of sources. Some of it could be leftover material from the formation of our solar system billions of years ago. It could be ancient dust that never quite managed to clump together to form a planet or a moon. Another possible source is the constant stream of micrometeoroids that travel through our cosmic neighborhood. These tiny space rocks can collide and break apart, creating even smaller dust particles. Over millions of years, the gravitational sweet spots at the Lagrange points would have slowly swept up this wandering dust, gathering it into the enormous faint clouds we are searching for today. To understand how these dust clouds can even exist, we need to talk about gravity. You probably know that gravity is the force that keeps you on the ground and keeps the moon in orbit around the Earth. But gravity is more complex than that. When you have two large bodies in space, like the Earth and the moon, their gravitational fields interact in interesting ways. They create a complex, invisible landscape of gravitational hills and valleys. The Kordylewski clouds exist because they are trapped in two of the deepest valleys in this landscape, where things can settle and remain stable for a very long time. At the L4 and L5 points, the gravitational forces of the Earth and the Moon are precisely matched by the centrifugal force of a small object orbiting with them. Think of it like swinging a bucket of water around your head. In a similar way, any dust at L4 or L5 is in a state of equilibrium. The pull from Earth, the pull from the Moon, and the orbital motion all cancel each other out, creating a calm harbor in the middle of a gravitational storm. This balance is what makes these regions natural collection points for space dust. Over eons, tiny particles drifting through the Earth-Moon system would have been captured by these gravitational traps. However, this balancing act is fragile. The Sun's gravity is the biggest disruptive influence. It constantly tugs on the Earth-Moon system and everything within it. This solar perturbation causes the L4 and L5 points to wobble slightly. This means that the dust clouds are not static. They are likely to be in a constant state of flux, slowly shifting, changing shape, and perhaps even losing some dust while capturing new particles. So the Kordylewski clouds are not just sitting there. They are active participants in the complex gravitational environment of our planet and its moon. They are a visible manifestation of the invisible forces that shape our solar system. For decades, the Kordylewski clouds remained phantoms, their existence debated and unconfirmed. But science and technology are always marching forward. By the 21st century, astronomers had a powerful new arsenal of tools at their disposal. Digital cameras with highly sensitive CCD chips replaced the old photographic plates. These new detectors were far more efficient at capturing faint light and could produce clean digital data that was much easier to analyze. The real game changer was the rise of powerful computers and sophisticated modeling software. With modern supercomputers, scientists could run incredibly detailed simulations of the Earth-Moon system. One of the most significant breakthroughs in the modern search came from using a clever trick of light called polarization. Sunlight is normally unpolarized, but when it bounces off tiny dust particles, the reflected light waves become aligned. A team of Hungarian astronomers and physicists, led by Gabor Horváth, decided to put this idea to the test. By using special cameras equipped with polarizing filters, they could essentially sift through the light. In 2018, after months of careful work, they found exactly what they were looking for. Their data revealed a distinct pattern of polarization that was significantly different from the surrounding background. The signal was weak, but it was unmistakably there. It was the strongest evidence yet that a cloud of dust was lurking at the L5 point. For the first time, a study using modern, sophisticated techniques had produced compelling, verifiable evidence. They had not just seen a faint patch of light. They had measured a specific physical property of that light that pointed directly to a collection of dust. It seemed that Kazimierz Kordylewski had been right all along. The ghost had finally been caught, not on a grainy photograph, but in the precise, quantitative language of polarized light. The consensus in the astronomical community has shifted dramatically. Beyond pure scientific curiosity, the Kordylewski clouds hold surprising importance for the future of human space exploration. Their unique location at stable Lagrange points makes them natural parking spots in space, requiring very little fuel for spacecraft to maintain position. The dust itself could be a valuable resource. If the clouds contain water ice, future astronauts could potentially harvest it. Water can be broken down into hydrogen and oxygen, the primary components of rocket fuel. The Kordylewski clouds might just be dusty oases in the cosmic desert. The ability to refuel at a Lagrange point station would revolutionize space travel, making long-duration missions much more feasible and less expensive. The Kordylewski clouds are more than just collections of dust. They are cosmic archives. Because they have been slowly accumulating material for millions of years, they hold a unique record of the history of the Earth-Moon system. Unlike rocks on Earth, which are subject to weathering, the dust in the clouds has been preserved in the cold, sterile vacuum of space. A mission to collect and analyze this dust could answer fundamental questions about our planet's formation. By studying the dust clouds right here in our own backyard, we can learn about the physical processes that govern dust behavior in space. This knowledge can be applied to understand distant solar systems and our search for other Earth-like planets. With the existence of the Kordylewski clouds now on solid ground, our quest is far from over. Understanding their exact composition, untangling their mysterious origins, and mapping their dynamic behavior are the great challenges ahead. The Kordylewski clouds are a profound reminder that our universe is filled with wonders, often hiding in plain sight. They teach us that there are always more secrets to uncover, even in familiar territory we thought we knew so well. The search for these dust moons has been a story of human persistence, ingenuity, and the unyielding desire to explore the unknown. The endless frontier is not just in the distant stars, it is all around us, waiting for us to look closer. From mathematical prediction to confirmed reality, the Kordylewski clouds have taken their rightful place as Earth's second and third natural satellites. They remind us that mystery and wonder can be hiding right next door, in the faint, ghostly glow of our own hidden moons.